Okay, ladies and gentlemen, here we go. This is still section 2.3. Okay, we're still talking about polynomial division, but I was going to show you quickly how to do some synthetic division. Okay, this is a little bit quicker than doing the long division. It does involve a different process, though, so you got to be aware of what it is that you are doing. Okay, so here, if we divide a polynomial here, boom, this could be considered p of x by a binomial, in this case, x minus 2. What I'm hoping that you know how to do already is synthetic division. So notice that we put the 0x, long division. Notice that we put the 0x squared in here to sort of fill in the place here. There's no x squared, so we put a 0 there just to be sure. Now, what we're going to do here is we're going to multiply the x by a 2x cubed, right, to give us 2x to the power of 4, and that becomes minus 4x cubed. We subtract this, right? That goes away. Minus 5 minus a minus is a plus. So what we end up having is a, what is it? Minus 5 plus 4, negative x cubed plus 0x squared. Now that's going to be multiplied by a negative x squared to give you negative x cubed. And then when you multiply it by the negative 2, you get positive 2x squared. Subtract that, that disappears, you get a negative 2x squared, bring the x down, plus x times negative 2x gives you negative 2x squared, and then minus 2x times that gives you plus 4x. You subtract these two, get rid of that, that gives you negative 3x, you have minus 4 coming down, boom, that came down there, that came down there, x times minus 3 gives you minus 3x, plus 6, and when you subtract that, you get a remainder of minus 4, minus 6, negative 10. Okay, so that process should be somewhat familiar to you. It doesn't take that long, as you can see, but what I'm going to show you goes a little bit quicker. Now, with synthetic division, folks, okay, what the difference is, look here, we use the factor here, okay, but I'm telling you that you use the solution instead of the factor. So if x minus 2 is your solution, your factor, that means x equals 2 is your solution, okay? Now that goes on the outside, kind of like your divisor here, okay? Now, the next thing that you need to understand is that we use the coefficients of the dividend. So we use the 2, the 5, the 0, the 1, and the negative 4. So 2, negative 5, 0, 1, and negative 4. All right? We put the coefficients alone only. We do not use the variables. Next step is we bring the first number down. So the first number comes down. There you go. Boom. And then we go through the process now. Every single time we got a number down here, what we do is we multiply it by this 2 out front or whatever is out here. So 2 times 2 is 4. There you go. So multiply by the divisor. And then the biggest difference, or one of the biggest differences, notice that here we always subtract. Well, with synthetic division, you add. Okay, so minus 5 plus 4 is negative 1. We multiply by the 2, it gives me negative 2. Add them up, you get negative 2. Multiply by the negative 2, you get negative 4. Add them up, negative 3. Negative 3 times 2 is negative 6. Add them up, negative 10. This last number here is your remainder. These numbers here are your coefficients of the reduced polynomial. You started with an x to the power of 4, a fourth degree. You divided it by x, which means that you're going to have an x cubed, right? Someone pointed out in class that you can actually just start out with this last number. If that's the constant, the minus 2 will have an x, the minus 1 will have an x squared, and the 2 will have an x cubed. That is another way to do it. Look at this solution, look at this solution. Notice that they are exactly the same. Okay, so we're going to look at a bunch of different examples with synthetic division. You're going to try them before I do. Maybe pause the video, give it a shot, have a look and see if you've got the right solution. Okay, so these are the steps that you need to take. These are the differences with synthetic division. Okay, so what do we have here? Let's have a quick looky-loo. Well, I got a couple easier ones here. Okay, so let's look at 3x cubed minus 2x squared plus 1. Notice again that you are missing an x. So if x minus 2 is equal to your factor, that means that x is equal to 2, right? So the 2 goes on the outside. What goes on the inside? The 3, the minus 2. I don't have an x, so let's put a 0 and a 1. First number comes down, 3. 3 times 2 is 6. Add them up, you get 4. Times 2 is 8. Add them up, you get 8. Times 2 is 16. Add them up, you get 17. That's your remainder. You have 3x squared plus 4x plus 8 with a remainder of 17. Okay? Now, what you want to think about is, if you have a remainder here, is this thing actually a factor of that? And the answer would be no. Unless, of course, you have a remainder of, that's right, 0. Okay, let's look at another one. Notice that a lot of these have those gaps, okay? So if x plus 3 is my factor, I'm looking at putting negative 3 out front here. I put the 4. Oh, do I have an x to the power of 4? No, I don't, so I put a 0. And then I put a negative 30. I don't have an x squared, so I put a 0. Then I have a negative 50, and I have a 2. Okay, this is a longer one. Now think about it. If you're going to divide a 5th degree by an x, you're going to end up with an x to the power of 4, right? So that's your answer will be a quartic, okay? First number down, times a negative 3. Add them up, times a negative 3. Add them up, times a negative 3. Add them up, times a negative 3. No, 3 times 18. 3 times 18. Not 48. 30, 54. Positive 54. Add them up, you get 4. Minus 3 times negative 4 is negative 12. Add them up, you get negative 10. Let me just make sure I did this right. The 4 comes down, boom, negative 12. Add them up. Positive 36. Add them up. Negative 18, add them up. 3, 30, 24, positive 54, add them up. 4. Yeah, okay, so now, like I said, this is a quartic, so 4x to the power of 4 minus 12x cubed plus 6x squared minus 18x plus 4 with the remainder of negative 10. Okay, process exactly the same every single time, right? Let's have another look at another one. This one looks a little bit funkier. Well, if 2x minus 1 is my factor, you're going to tell me that your solution is 1/2. Okay? Now, this one's going to end up being a little bit different, because another way to look at that your x is 1/2, what you can do is factor out the 2, because if you want to find the proper solution, you need to only have a 1x here, right? So you can look at 2x minus 1 and note and see that it's the same as factoring a 2 out. You have x minus 1/2, right? And then you can see that 1/2 is the number that goes outside here. It's your divisor, right? Let's make a little bit more room here. And that should be up top here, but it doesn't matter. So we got 6. Then let me give you a bit more room here. So 1/2, boom, boom. And we got a 6, a minus 7, a 4, a minus 11, and a plus 9. So the 6 comes down. Half of 6 is 3. Add them up, you get negative 4. Half of negative 4 is negative 2. Add them up, you get 2. Half of 2 is 1. Add them up, you get negative 10. Half of negative 10 is negative 5. Add them up, you get 4. So you got a remainder of 4. Now, 6x, well, we had a quartic divided by an x. 6x cubed minus 4x squared plus 2x minus 10. Now, this type of example, ladies and gentlemen, because you have a fraction here, notice that you factored out a 2. So you kind of have to factor out a 2 of this. You got to divide everything by 2. So your real answer would be all of this divided by 2, which is 3x cubed minus 2x squared plus x minus 5. That would be the actual answer in this case. Now, there is an explanation kind of for this. I can show you an example. We can do it with the quadratic in class. I'm just going to ask you for right now to kind of remember that thing, okay? When you have a fraction here, or when you've got this binomial that's a little bit different, you have a coefficient in front, then you're going to have to do some division at the end. So if it was a third here, you'd have to divide by 3 at the end. Okay, if it was a quarter, you have to divide by 4 at the end. Now, the last one I want to show you is a little trickier. Okay, I wouldn't suggest doing synthetic division with these questions, but it is possible. Okay, and it's only possible if you have this situation. Well, notice that this quadratic here is a combination of 2 binomials. Okay, where you have an x equals negative 2 and an x equals 2. Those are your solutions. So what you do is you take one of those solutions. Let's start with the positive 2. and then we put the coefficients like we did before. There's none here, so it's a 1, and then a 9, a minus 36, and a 4. Okay, so process exactly the same. 1 comes down, boom, times 2. Add them up, 11 times 2. Add them up. Times 2, 34. Add them up. You end up with a negative 2 times 2, negative 4. You have a remainder of 0. This process will only work if you have a remainder of 0. Now, this is your solution. It's 1x cubed plus 11x squared plus 17x minus 2. So what you're going to do now is divide it by the other one. It's minus 2 now. And we put these coefficients in. 1, 11, 17, minus 2. So the 1 comes down, times negative 2 is negative 2. Add them up, 9, negative 18, negative 1, plus 2, remainder of 0. So x squared plus 9x minus 1. This is the way to do these longer ones. Let me just see if I can put it all together. So this is your original question, okay? Now, and I've got your answer here. So what it ends up being is this. Look, x to the power of 4 plus 9x cubed minus 5x squared minus 36 plus 4. What you just did was you divided it by both of these here. Okay? You divided it by both of them, which means that you can divide it by one of them, which is what we did here, and then you divide it by the other, which is here, right? So now the answer then would be, okay, so what you have here, hold on a sec. Let me just write this out again. So x to the power 4 plus 9x cubed minus 5x squared minus 36x, plus 4 is equal to, well, I've got these two things here. It's equal to, so x squared plus 9x minus 1, right? Times x plus 2. I'm not even actually sure what's going on here. Anyways, yeah, that's right. There you go. That makes absolute sense. So if you multiply all these things out, you'll end up with this thing. Now, if you want to break it down into all its factors, we should see if we can actually factor this thing here. Unfortunately, we can't, but we've got it broken down into its component parts as much as we can. Here again, quickly, if you wanted to pause it to have a look and see what happened, then hopefully it will make some sense. Any questions, folks? We can talk about this anytime you want.